Math 1108 Test 4 Review Sheet, Section 9.8, solve quadratic inequalities and write solutions in interval notation and algebraic notation. Okay, when solving quadratic inequalities, we want one side to be 0, and then we find the endpoints by solving the quadratic equation that we get by replacing the inequality with equals. So we can solve this one by factoring. One factor is x minus 7 and the other one is x minus 4. So the endpoints of the intervals, the endpoints that divide the number line into separate intervals, are x equals positive 7 and x equals positive 4. So on the number line, we plot the numbers 4 and 7. They divide the number line into 3 separate intervals. And then we pick a test point from each interval. And in the inequality, replace x with the test point and check to see if the resulting inequality is true or false. In the first interval, we can pick any number less than 4. So since 0 is in that interval, that's a nice number to work with. And then replace every x with 0, we're left with 28 is greater than or equal to 0. And that is true, so that means all of the numbers from negative infinity up to 4 are solutions. In the second interval, pick any number between 4 and 7. I'll pick x to be 5. And then in the inequality, replace every x with 5. So 5 to the second is 25. And minus 11 times 5 is minus 55, and then plus 28, greater than or equal to 0. So this is negative 30 plus 28 is negative 2, greater than or equal to 0. And that's false, so none of the numbers between 4 and 7 are solutions. In the third interval, pick any number greater than 7. I'll pick x to be 8. So in the inequality, replace every x with 8. 8 squared is 64, and then minus 11 times 8 is minus 88, and then plus 28, greater than or equal to 0. So 64 minus 88 is negative 24. Negative 24 plus 28 is positive 4. Positive 4 greater than or equal to 0 is true. So yes, all of the numbers from 7 to infinity are solutions. Since the inequality is greater than or equal, we do include the endpoints because each of the two endpoints is what makes x squared minus 11x plus 28 equal to 0. And 0 greater than or equal to 0 is true. It's the or equal to 0 that makes it true. So graphically, we put a bracket at each of the endpoints, and then shade in the rest of the solution, a bracket at 7 and shade to the right. The interval notation for this set of numbers on the left, this is parenthesis negative infinity comma 4 bracket, and then the union symbol, and then for the other set of numbers, bracket 7 comma infinity. The algebraic notation, this part of the number line is x less than or equal to 4. Then we write the word or, and this part is x greater than or equal to 7. Okay, in the next example, x squared plus 7x minus 18 is less than or equal to 0. So we want to find the endpoints by solving x squared plus 7x minus 18 equals 0. Well, we can solve this one by factoring also. One of the factors is x plus 9, and the other factor is x minus 2. So the endpoints are the solutions to that equation, x equals negative 9 and x equals positive 2. So this time we plot negative 9 and 2. We have 3 intervals to test, just like in the previous example. So on the first interval, pick any number you want less than negative 9. I'll pick x to be negative 10. And then in the inequality, replace every x with negative 10. So negative 10 squared is 100. And then we're adding 7 times negative 10, so that's equivalent to subtracting 70 and then minus 18. less than or equal to 0. So this is just 52 less than or equal to 0, but that's false. So none of the numbers from negative infinity to negative 9 are solutions. In the second interval, we could pick x to be 0, replace every x with 0 in the inequality, and then we're left with negative 18 less than or equal to 0. That's true. So yes, all of the numbers between negative 9 and 2 are solutions. And in the third interval, we can pick x to be 3, and then replace every x in the inequality with 3. 3 to the second is 9, and then we're adding 7 times 3 is 21 minus 18, less than or equal to 0. So 30 minus 18 is 12, but 12 less than or equal to 0 is false. So none of the numbers from 2 to infinity are solutions. Once again, we do include the endpoints because those are the numbers that make the left-hand side 0, and 0 less than or equal to 0 is true. So graphically, we put brackets at the endpoints, and the interval notation for this set of numbers is bracket negative 9 comma 2 bracket, and the algebraic notation, negative 9 is less than or equal to x, which is less than or equal to 2. Okay, in the next example, we have negative x squared plus 7x minus 10 is greater than 0. So what I advise on this one, since the coefficient of the x squared term is negative 1, multiply every term on both sides of this inequality by negative 1, and then switch. Doing so means you have to switch from greater than to less than. But the arithmetic will be easier if the leading coefficient is positive instead of negative. So we'll just work on this inequality. The solutions to both are the same, but this is easier to deal with, in my opinion. So once again, to find the endpoints, we have to solve the equation x squared minus 7x plus 10 equals 0. And we can solve this equation by factoring again, so x minus 5 times x minus 2. So the endpoints this time are x equals 5 and x equals 2. So I'll plot the numbers on the number line. 2 is to the left of 5. So we have 3 intervals to test. So on the first interval, pick any number you want that's less than 2, like 0. You can use any inequality that you want, but I'm going to use this one after I multiply both sides by negative 1. So replace every x with 0, we get 10 less than 0. That's false. So none of the numbers from negative infinity to 2 are solutions. In the second interval, we can pick any number between 2 and 5, so I'll pick 3. And then in this inequality, replace every x with 3. 3 to the second is 9, minus 7 times 3 is minus 21, and then plus 10 less than 0. 9 minus 21 is negative 12. Negative 12 plus 10 is negative 2, and negative 2 less than 0 is true. So all of the numbers between 2 and 5 are solutions. Then in the third interval, pick any number greater than 5. I'll pick 6. And then in this inequality, replace x with 6. 6 squared is 36, minus 7 times 6 is minus 42, and then plus 10 less than 0. 36 minus 42 is negative 6. Negative 6 plus 10 is 4. But 4 less than 0 is false. So none of the numbers from 5 to infinity are solutions. And this time the endpoints are not in the solution set because the inequality is just less than 0. So we put parentheses at the endpoints when they are excluded. The interval notation for this set of numbers is parenthesis 2 comma 5 parenthesis. And the algebraic notation is 2 less than x, which is less than 5. Okay, we'll do some problems from 11.1. 11.1, the distance formula and equations of circles. Find the distance between the points 6, -7, and 8, -5. So the distance formula, just to remind you, the distance between x1, y1 and x2, y2 in the xy plane is the square root of x2 minus x1 squared plus y2 minus y1 squared. Positive square root of that is the distance. It doesn't matter which pair you order as x1, y1 and x2, y2. So I'll just pick 8 minus 6 quantity squared, and then plus -5 minus -7 quantity squared. Be careful with the arithmetic, and then just do the arithmetic. 8 minus 6 is 2, 2 squared is 4, and -5 minus -7 is -5 plus 7, which is 2, and 2 squared is 4. So we get the square root of 8, and then simplify the square root of 8. That's 2 times the square root of 2. Okay, in the next example, find the distance between the points -10, 5 and 3, 2. Okay, so we already saw the distance formula. So the square root, I'll write -10 minus 3 quantity squared plus 5 minus 2 quantity squared. And then we'll do the arithmetic. So -10 minus 3 is -13, and -13 squared is 169. And then we add that to 5 minus 2 squared. 5 minus 2 is 3. 3 squared is 9. And so we get the distance is the square root of 178. And let's see. So I don't think that can be simplified further. Okay, in part C, this time we'll write the standard equation of a circle centered at -5, 4 with radius 3. So just to remind you, x minus h squared plus y minus k squared equals r squared. This is the standard equation of a circle if the center is the ordered pair hk and the radius is the square root of r squared, or r. Okay, so we're given the x and y coordinates of the center, so it's x minus -5 quantity squared plus y minus 4 quantity squared equals 3 squared. And we normally do more arithmetic. Instead of writing x minus -5, we write x plus 5 squared, and then plus y minus 4 squared. And instead of writing 3 squared, we just write 9 in its place. So this is the standard equation for the circle centered at -5, 4 with radius 3. Okay, the next one is the same kind of exercise. This time the circle is centered at 7, 2, and radius is 8. So we'll just write x minus 7 squared plus y minus 2 squared equals 8 squared. I'll just write 64 since that's what you get when you square 8. Okay, and then in the next video we will look at more equations of circles.